Good morning and welcome back. Today we're going to be looking at how we can do some more sorting with arrays, and we're going to be doing some cool stuff with that. So that's what we're going to be working on today. We want to start, however, with a private helper method we're using so we can display the timing information. We want to see about how long something actually takes for this to occur, and so we're going to be using a time function so we can actually grab that information. So we have that private string method named parse time. It takes a long parameter named time. I know, crazy, boring variable names that I do by default. But if you haven't worked with it before, long is a data type that holds a integer type value, but instead of having just plus or minus 2 billion in change, it's plus or minus 9 quintillion in change, aka it's huge. We're using that though because we're talking about nanoseconds, and nanoseconds, if you don't know, are little itty bitty parts of a second. I know, crazy, but if you want to have a great example, if you want to have a great example of what nanosecond is, Google, look on YouTube for a quick video of Rear Admiral Grace Hopper talking to David Letterman about nanoseconds. She can really give you some explanation about that, and she's funny, and she's amazing, and she's the first major, huge she's the first Rear Admiral of the U.S. Navy that's a female, and she's an amazing discovery for computer science. There's so much about her, can't say enough. Rear Admiral Grace Hopper, fantastic human being, total thumbs up. Yeah, but back on track. So the first thing we have string parse is equal to time plus elapsed nanoseconds, so we can get an idea of the time. Now there is one thing, when we're using this right here, the nanosecond time we're working with in Java can be negative. That doesn't actually affect us, so if you see a negative number in here, it's not that we went back in time. I wish, but no. It just simply says it's just where the arbitrary starting point that it's using to calculate that time could be negative. That's okay. So no worries there. But, so if you get a negative number, don't worry about it. So parsed is going to be plus equals time divided by 60 billion. Now I'm using this underscore right here to separate the values like we'd normally use a comma in America or a period in France. And so we're using that to actually group those things. It also makes it really easy for us as a human being to see with our eyeballs. Because if you ever have tried typing out a number without using commas to separate it, it looks really weird. But by using the underscore to separate those values, we can more easily read that as a human being. It's a great thing for us to do. Last thing I want you to note is there's an L right here. That's not a 1, it's an L. That's to indicate to the Java compiler that we're explicitly typing out a long value. And so that way it doesn't try and read it as an int, because that won't fit inside int. 60 billion, way outside plus or minus 2 billion, not going to fit in there. So I'm using that L at the end of that to indicate that it's explicitly a long value. It's a great practice to do when you're dealing with big numbers, okay? And so that's in minutes. So when I divide time by 60 billion, that's how many minutes we have. And then I use the time modulo equals 60 billion. So I'm going to divide it at, and I'm not going to keep the answer, I'm just going to keep the remainder, because remember modulo is the remainder division. And so by doing that, I have only the leftover part after I've done the division but for minutes. So I'm converting formats here. So now I've got that no value of time, which has it stored in seconds. So I do that same thing, parse plus equals time divided by 1 billion. Now again, even though 1 billion fits within the realm of an int, I'm doing this with an L again, just because it's a nice little quite, hey, I know this is an int. Okay, cool, I know this is a long value. We're great. And so I divide that by 1 billion to get the number of seconds I'm working with. Then I go to my time, and I do modulo equal 1 billion again. So I'm dividing and only keeping the remainder. So now all my seconds are gone. Now I'm left with milliseconds, microseconds, and nanoseconds. Same process again, parse plus equals time divided by 1 million to get my milliseconds. Oh, cool, great. And then time modulo equals 1 million, so I can grab that again. And then so I'm using that underscore again to separate those values, make it really easy for my eyeballs to read it. So as a human being, I know exactly what that value is. Then one more time, modulo equals 1,000. I'm into my nanoseconds now, and I return that string that's been built up. So I have now a string value with lines for each value, so I can easily read what's inside it. Makes it easy for my brain to see the time. So that's what we're doing right there with the parse time method. It's a helper method I can use to see the times we're working with. I'm going to go into my start method. I'm going to comment out the method I'm working with. So we're going to be working with advanced sorting demo. That's where we're going to start off today. So now I'm going to go to my advanced sorting demo method, and we'll open that up and we'll talk about what we're looking at first. The first thing we're going to do is we're going to create an int array named data. That's a new int array. It's 500,000 ints big. I know. I'm giving a ridiculously huge size of data set here though, because we actually want to see what is the impact of using the built-in tools for sorting. It's even better than the one that we wrote for our selection sort with the demo, because again, it's an optimized sort that has already been pre-compiled, and it works really well. We'll talk about that another time. Well, actually, we'll talk about it in just a bit when we get to it, but we'll get to it there. I have that same size array for slow sort data with the same size, 500,000 for that new int structure. So like, oh, that's how many things I'm putting inside that. So I have the same value right there. And then I'm going to iterate over the array, and I'm going to put a new random value in both of the arrays. And in fact, I use the same value for each spot. So it's the same type of sort that we're going to happen. So we have a new random value that's going to be attached to that. Again, when we're working with Java and we want to get a random number, we do math.random. We multiply that value times our scalar. We wrap that in parens because we want to get that entire value first, and then I cast it as an int. Because again, Order of operations matters, parens first, so keep that in mind. All right. So then we're going to go ahead, we're going to build a couple strings right here. We're going to keep track of this time. So we have a string unsorted nums is equal to blank and string sorted nums is equal to blank. And we're just going to go through the first array. We're going to grab the first 10 values just to see what's inside there. And I'm going to say index is equal to 0, index is less than 10, index goes up by 1. This is just so I can grab the first 10 values and see what's inside that array. So we can work with this in just a bit. Then I'm going to I'm going to set a long fast sort time equals system.nanotime. Again, we're using the nanoseconds that elapse between this because computers operate on such a much faster level than us. We think in terms like, oh, a second might be sometimes, oh, I had to wait a few seconds, no big deal. I waited half a minute, oh, that's a bit of time. I waited 3 minutes for this. Yeah. Computers think in time where a second is huge. It's a massive amount of time. We're measuring things in microseconds, milliseconds, nanoseconds, picoseconds. That's regular computer speed stuff. For us as humans, that's like instantaneous. But for a computer, it's actually, oh, I can tick, 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 tick. We can't do that as humans. We can't even say the thoughts that fast. But that's how computers operate for that structure. So now we've got that lovely little bit right there. We're going to say long fast sort time is equal to system.nanotime. Then I'm going to call the Arrays.sort data. Arrays.sort, wait, arrays have no thing. Well, no, this is arrays. So arrays is the Java helper class. We have to go up here and of course we have to add an import for that inside our lovely project. So I have java.util.arrays. So it's a built-in helper tool that allows us to do functions with arrays. There's some great ones in there. We're going to use sort today, but if you take a look at that on the Java API, there are some great features totally worth looking at. Definitely want to take a look at those and use some cool stuff with that. But we're using the Arrays.sort method. And so the Arrays.sort is going to do the sort on that array. And again, because we're passing the array as a parameter, we don't have to return anything. It simply just it sorts the array inside that structure, and we have that same array we can talk back to. We'll do the same approach with that using the long slow sort time passing system nanotime, and then selection sort passing the duplicate array slow sort data, the same thing we just made. And so now we have that lovely two arrays, and we use the minus equals system nanotime, so I can subtract the later time from the time we started off with, which gives us the difference. Once we've done those two iterations, we're going to pass those long values, we're going to pass it to our parse time method we just went over at the beginning of the video, and we'll return the string to that, and then we'll do a display message using our pop-up class to say, oh, here's the fast speed, and then here's the slow speed. And we use the versus slow on that so we can easily identify what's happening with that. Now, before I actually run this code and talk about it, I want to remind you that when we're talking about the idea of this, there's a whole different level of execution speed on this, and so this is actually going to take measurable time. In fact, we're going to cut some time out of this because I'm not going to wait a full minute and a half or whatever it's going to take to make that happen, because that would be too much time. So I'm going to go ahead and hit play, and we're going to run this code. And when I run the controller, okay, cool. And I say okay. And we're going to wait for this, and we're going to wait for just a smidge. And once it pops up, then we'll go over it, and we'll see how long it actually took in comparison working with those two different structures and how fast they were able to sort them using the two different tools. So that's where we're going to go from there. Hang on just a bit. We'll come right back. 163,153,500 elapsed nanoseconds. Okay, that's really fast. 0 minutes, 0 seconds, about 160 milliseconds, 153 microseconds, and 500 nanoseconds. This is our slow version. Whoa, that's a lot bigger. 1 minute and 53 seconds, basically 2 minutes of time. So the entire time this takes, 160 milliseconds, is on this one almost a third of what just the remaining time after the 2 minutes. This is so much faster. Now, if you take a look at why that's happening, look at the Java Arrays API. You can see that the fact that the Arrays API sort method uses what's called a dual pivot quick sort, which is so much better than selection sort. Great little read on that. You can see how to make that happen. So our selection sort, bad choice. It's much faster than us as a human. There's no way a human could do this in 1 minute 53 seconds, but the computer, hey, that took some time. We've got that happening. So we've got a really amazing thing we can do with that, but this is so much faster by using the Arrays.sort. So again, we have these built-in tools that are amazing. We should definitely learn how to use them. And so that's where we have right here on that lovely bit right here, where I have that fast time versus the slow time on that, and we grab that. Then we're going to scroll down, and we're going to see what happens within this. And so our next bit right here, we're going to go index over for 0 up through 10. And we have our sorted numbers, and we have sorted numbers, we're going to index plus and then a space. We can sort them all out. And so the first 10 values on there were 599, so 59,915, 20,045, 30,107, 37,247, da 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 da. And then sorted, I have 3 zeros and a bunch of 1s and a 2. So I've totally gone through and I've sorted that data. So my data is sorted. It just took a lot longer to make that happen. So that's what we're having happen with that. And then let's go ahead and take a look at this with a debug duck. A debug duck is our next kind of data structures. We're using it so we can actually learn how to ask questions with that. And we want to be able to sort debug ducks. And so to do that, we have the same type of thing. I'm going to make 500,000 debug ducks. Now, with a debug duck, it's an object. So if we go ahead and instead of previously we were just sorting a quick little primitive, just an int, which is basically free in Java land. But now I've got an object, so I've got the whole weight of an object itself that I'm going to carry. And inside the object, we have two data members. We have an int and a string that we're working with. And so I'm going to sort those debug ducks. So I give it a name. So it's a duck number and its index. And then duck.set question count. And I give it some random number for its question count, so I don't know how many how many questions I've answered. And I assign that new duck into the duck subindex. And so I'm going to go ahead and grab the unsorted names, the sorted names, and then I'm going to grab those names and put them into a string, just like we did before. And my long duck sorting time, system.nanoTime, arrays.sort, and then my sorting time for that giving minus equals nanotime again. And then I'm going to go ahead and grab the names for sorted so we can see what's inside that. And I'll get the parse time for that. I'll do the parse time, and I'll display my duck time and display the unsorted and the sorted names. So I press OK on that, and we're going to wait again just a second. And so we have that lovely bit. So we have a negative 682 elapsed nanoseconds. So 682 milliseconds. Now that's a bit of time. That's more than that's more than 3 times what we had. That's more than 4 times, in fact, what we had for just sorting that 500,000 array of ints. But notice it's still using quicksort. There's still no seconds involved. There's still no minutes involved. So even though I've added an object, it's still taking time. One of the things we can use as an example for this. So say for example, I'm doing my weightlifting, and I'm using my weightlifting. And I'm using a really tiny weight. In this case, a glasses container. Now, if I use my weightlifting, I do my bicep curls with a glasses cleaner like this, okay? This is just basically body weight that I'm doing like that. Now, that actually does work by muscle. It does take in time. But simply just doing this, but if I'm doing this 500,000 times, oh, that actually will build muscle for my arm. But wait, if I take this and I take a debug duck, and I take my debug duck and I put it with that paper, and I put something that's also basically free, we'll put another piece of paper in there. Take another piece of paper in there. So I've got my debug duck with its string and its number. And now doing that, even though it's tiny, it's just a little bit more. I can actually feel the weight that I'm doing with this, and that will provide even more work as well. And so I'm actually doing work. So that's where we get that 682 milliseconds. It's more than 4 times as much as the work it had to do to actually do the sort with the 500,000 ints, but it's still basically 0. 682 milliseconds is, well, woohoo, that takes 0 time. It's just over half a second. We're like, no big deal. So we've got that happening with that right there. And we say OK on that one more time. And then we've got our lovely duck information. And so my unsorted, we have duck 0, duck 1, duck 2, duck 3. And I didn't print out the numbers that are attached to that because again, just trying to give a quick little demo for that. But my sorted version, duck number 98, duck 1607, duck 30,020, 3121, 6883. And so now we can see that we have those values that are stored in each of those ducks are clearly different from the original named-based order. So we have that right there. So it's a great way we can actually see, oh, here is some actual information we're working with. Here's what's going on with that. And so I can have that new sorted information. So again, we did that by making this happen. So just a quick review of what we did. I'm going to go ahead and close this screen right here because I don't need that. We're going to go back down here. We made our parse time method. The parse time method is how I can go through and I can calculate the amount of time that takes by taking the nanoseconds, and I use the magic power of divide and then modulo equals in sequence to get the different levels of time. You may remember this from your math class, your physics class. We were doing the idea of conversion between units. I know, yep. So I used that parse time method to do that. I went through and I quickly generated some random values in arrays, and we saw the fact that using an int array of 500,000, it takes basically nothing to sort that when we're using the arrays.sort method, but it still takes almost 2 minutes to sort it using our selection sort. So when we're talking about actual large numbers of values, when we want to use the tools that are available for us rather than writing our own sorts, like say for example selection sort, which don't do the work that we're looking for. And we can do that. We also saw that when I sorted an object of 500,000, the same amount of actual space for memory, like, oh, there's 500,000 entries in that, it was still 3-4 times as big as the time it took to sort those 500,000 ints. And so we have the fact that when we're working with an int versus an object, there's a definite speed up effect because sorting small data is easier than sorting bigger data. Because again, it's like when you're lifting into a single paper, that doesn't cost as much as lifting an object does. And so we're taking that in consideration. We can do some cool stuff with that. And again, if you want to use the arrays.sort, and remember, you do have to add that import in there from a java.util.arrays to have that import inside your project. Hope that was helpful. Cheers and have a great time. See you next time.